On this week's MetPy Monday, we'll look at a data type that you've likely never used before, the Enum. Welcome to another MetPy Monday. Hello, I'm John Lehman, a software engineer for Unidata. This week we're going to talk about a data type that, unless you've done a lot of programming in C, you may not be familiar with, which is the enum, or the enumerated object. Now, we're used to the idea of enumerated things in Python, and the enum doesn't stray too far from that concept, but fundamentally, an enum is a restricted set. So this is sort of related to slots that we talked about last week. And it's a way to code things. So instead of saying, okay, we're all going to agree that a integer 1 represents a tornado report, an integer 2 represents a hail report, an integer 3 represents a wind report, and so on, we're going to create this data type enum so we can use those aliases, tornado, hail, wind, to represent those items, but they're actually stored as that integer under the hood, if you will. So this is a restricted type, meaning that once we declare it, we can't suddenly have an integer 6 creep in, which you could if you were just using a generic integer. And we can use the names, so it's sort of like a dictionary, but there are some other benefits that we'll see. So first, let's see how to create a basic enum. So from enum, I'm going to import the enum object. I'm also going to import numpy and import pandas. So we're going to make a instance, or we're going to make a class that inherits from enum. So class, and I'm going to call it report type, enum. And then we're going to just define tornado is a 1. Hail is a 2. Wind is a 3. And let's call flooding a 4. Now you can also have multiple aliases. So, we could have whirl equals 1 if we wanted to. There's some other cool things that you can do with enums, but we're really just going to focus on the basics for this Monday. I'm going to create some fake data. Let's make some fake lats between -90 and 90. And we'll make the size be 100. Now we'll do the same with lawns, except the lawns are going to run from -180 to 180, and then our report type. So I'm just generating some fake reports here. You can think of these as Storm Prediction Center reports or whatever you want. It's an integer between 1 and 4. And now I'm going to make a data frame. This is just showing a handy way that we could use the enum type here. Latitude is lats. Longitude is lawns. And report type. So now if I look at my data frame, we see in the report column, I just have, and we'll just do head here. Okay, so we see here now that we've got our data frame, and in the report column, we have an integer. Now we haven't coded that integer yet, we just created it with randint here. So I'm going to replace that using a list comprehension. I'm going to create a report type enum of R for RNDF report. So what's this saying? It's saying take my integer r for each one in report, and we're going to make that an enum of that integer. Okay, so now if I look at df.head, we see that I've got the report type in the report column. And now I can get fancy and do things like show me items in the data frame where the report is equal to report type dot tornado. And there we have all of our tornado reports. That's a lot easier to read code-wise and to comprehend as a human than show me where report is equal to the integer 1. Also, you can't get any other report types in here. We haven't created a report type for the integer 6. So if I try to create an instance, I get a value error. But if I try to create it on a valid type, there we go. Also, that means when I'm making this query, if I misspell something, it's not going to work. So again, this being a restricted type, that's a handy thing. Now, for those of you that are Pandas pros out there, you might say, actually, Pandas already has a tool to handle this kind of mapped data. And you're right. So that's just an example to get us a little more familiar with the enum, and you certainly can use it in this context. But let's look at one of the cooler things that we can do with it, which is adding things like class methods to it, or using the enum in our functions. So first, let's create a function called myFilter, and it takes data and then some parameter I'm going to call the aggressiveness. And this is just a fake filter, so we'll add our doc string, fake filter for demo. Now, my aggressiveness values, I want the user to be able to specify as small, medium, or large for how aggressive my filter is, and then we'll apply that to our data. All right, so that might look something like if aggressiveness is equal to small, size equals 1. If aggressiveness is equal to medium, size equals 5. If aggressiveness is large, size equals 10, else raise a value error for invalid filter aggressiveness. And then I'm going to return data times size. That's my fancy filter. It's just a multiplier. So our code for our filter is relatively small and buried in our function. All of this input handling is taking up a lot of space and making it harder to actually get to the point of what the function does. Now, does it work? Sure. We can create some data, mp.random.random, a size of 10. If I call myFilter on data small, we see we get integers in the interval 0 to 1. If I call myFilter data large, we expect those to be multiplied. And there they are, multiplied by 10. Okay, so that's great. Let's check what happens if we misspell small. All right, we raise a value error, invalid filter aggressiveness. That's great, but like I said, that's kind of ugly code. It certainly works though. And there are a lot of functions that are out there that have these string inputs. For example, the method of operation on convolution. But what if we could do this with an enum? So let's try it. All right, so I'm going to create a enum filter options. Small is going to have the value of 1. Medium is going to have the value of 5. Large is going to have the value of 10. Notice these don't have to be consecutive integers. All right, so there's our enum. So now the code for myFilter, data and aggressiveness, just becomes return data times aggressiveness dot value. And I can call myFilter our data D and filter options dot large. And there we get the same results. So this works nicely. It handles invalid inputs and it hides the implementation from the user a little bit more. Okay, that's great. We can go one step further. And this is where enums get really cool, especially if you're used to just regular enums like in C. We can actually put a class method on this enum and make it have a little bit of intelligence here. Okay, so I'm going to define a class method with the class method decorator. And it's going to be best for time scale. It's going to have our data size as the input. And class first, just like you would have self in a normal method. So if data size is less than 1, return filter options dot small. Elif data size less than 10, return filter options dot medium. Else return filter options dot large. All right, so what's this do? Well, let's say that I wanted to provide some sort of way for my user to say, here's how big my data is, suggest the filter parameter for me. Well, this enum now has this class method on how to do that. So I can now call my filter on data, and then instead of passing in small, medium, or large, on the filter options enum, I can access the best for timescale class method and pass it my data size. So if I tell it my data is 100 in size, then we would get the multiplier of large. 10, we're going to get the same thing, but once we go down to 9, we drop down to 5. And if I tell it that my data are 0, then we get the multiplier of 1, or the small. So again, that's kind of a toy example, but it really shows you how you can take something relatively straightforward, like an enum for a filter aggressiveness or filter size, and start adding these class methods to make it even more useful. I hope that you'll try using the enum in some of your code and help make your code a little bit more friendly for you and whoever else has to use it. I'll see you on next week's MetPy Monday.